How is everybody today?
It's another day in paradise.
Cool. Okay, so one of the first things we want to do to get started today, because we want to continue with that quick example that we built yesterday. So I'm going to actually take that Echo demo project that I've got, and I'm going to duplicate it. So without Android Studio open, just go take the folder, copy it. I'm going to paste this and rename this as Echo Demo 2. Because we're going to do enough to it that I just want to make sure that we're on a not building on top of that project and keep the original that we did yesterday. Cool. So once you've got the project copied, I'm just going to open that up in Android Studio. So file, open that up, and so where's that at? Here. Volley examples, and I'm going to open up that Echo Demo 2. So there's just a few things we want to kind of flesh out. We didn't, because we ran out of time to cover them yesterday. One of those is how do you build out some custom requests, because you're going to need to do that. How do you fill in and incorporate JSON to parse the JSON data, and how do you use the work manager with it as well. So, we kind of covered the basics of how to use Volley yesterday, but we need to talk about how to incorporate it and make it work with other technologies. Does that make sense?
Yeah.
So the first thing I want to do is add some dependencies. So I'm going to go into my build Gradle. You can see we've already got Volley in there, but I need to add in JSON so that we have that for parsing our JSON data. So I'm going to add that in, and that's the line that we're adding here. Go ahead and share that in Discord, so you've got a copy of it. So we're going to bring in the JSON library using that statement. I also, while we're here, I'm going to go ahead and bring in the stuff that we need for the work manager as well. And we actually need 2 dependencies to work with the work manager today. So I need the work runtime dependency, as well as this concurrent futures dependency. That's not one that we've used before. That's a new one. That's related to things that we have to do in order to get the workers and Volley to work together. You have to implement your worker a little bit differently because it's running on an async task instead of running synchronously. So, when we had written things with the URL connection, then we just were writing things and it was running on the same thread. That is running on that background thread. But because Volley spins up its own background thread, we have to do something a little bit different. Okay, and so that's where that other dependency comes in. The Android X concurrent dependency is needed for one class that we need from there to make this work. Is everybody with me there? Have you got your dependencies pulled in?
I'm still catching up.
Yeah. Okay. Could you just paste that in the chat?
Already did.
Oh, okay.
Already did. So, it's just, as far as what we've done so far, duplicate the project. We're going to call this Echo Demo 2, and they're just adding in those dependencies. So, given all that, you should have 4 additional dependencies, which is what I have here. The Android Work, Concurrent, Android Volley, and Google Code JSON.
Is there any reason you would add stuff to Gradle but you wouldn't sync it? I'm just curious why that is never synced automatically.
I think it's just a matter that it takes time for that to run. And it also means that anytime you hit sync, it has to go connect to the internet and potentially download files. So it's just, I think it's really just a matter of letting you determine when you want to do the sync. And that would be more important if you had low connectivity, especially.
Oh, okay.
Or your connectivity was charged, because that sync can lead to some pretty large downloads sometimes. We're talking about, maybe you hit sync and it downloads several gigs of data. You may want to, the ability to say when that happens. So that's all it is. I think I might actually just post this.
Does the order that you list the dependencies matter in any way, shape, or form?
I think that sometimes it does. In this case, I think you can list those 4 in any order you want.
Okay.
So I'm really just organizing them in 2 orders that I'm using them, but also kind of semi-alphabetically, more alphabetically than anything. So, but yeah, no, in this case, you can list those in any order you want. All right. So once you've got those dependencies in, then we can actually start working with and making the code. So the first thing I want to do is we're going to make 2 custom requests classes. So we're going to make one that can contact the echo service as a GET request. We're also going to make a version that can contact as a POST request. So we can kind of see, how you do both and what some of the differences and some of the things you might want to consider as you're making, say, a GET request or making a POST request to an API. Because those more likely will mean that you're sending the data or setting it up differently. So we'll talk about that. But in order to enable us to get there, we also need to have a place to store the data. So you remember that we usually start by building out our model. So that's where we need to start, right? So we need to build out what is the model, what is the data that we're getting back. And so if you remember from yesterday, it always returns timestamp as a property, but it also returns whatever else that we send to it. So if I send a message, it will return a message. If I send a number, it will return that number, all those kind of things. So I'm going to add a model class here. I'm going to call this, what am I going to call this? I'm going to call this Echo API Response. So this is the data that we're going to be receiving back from this API. And so we've kind of talked about some of this already. You really just have to model and figure out what the data is, what does the data look like in the JSON that I'm getting back. So what I'm going to do in here, because I also want to add in something for, say, knowing if this is a GET request or a POST request, I'm going to add in another field as I'm doing this called this method. So in terms of the API response, I'm just going to say, well, we want to see a string, which is the method. We want to have a message, so we can see that whatever data the user entered went to the server and came back. This is message. and public string timestamp. And so that's really all I need for my model classes, my model class here. So we're going to have a method, a message, and a timestamp, and that should have 2 S's, not 3. Any questions on that right now?
That's your top level, right? That's the top level thing for the object, right? If there was an array or something within that Echo API response, that would be defined elsewhere.
Right. So if I had like a list of objects in there, then I would need to say, yeah, an array of objects. I would say list of other thing, right? So
Yeah.
this will vary based on what you're actually getting back from the service. In this case, this is just a pretty simple case, so building out the model is not too complex. And that's kind of what I want for this example, so that we can focus on the other pieces. Not so much focusing on the model and the complexities there, but focusing on the other infrastructure that we need to set up to just get data back and forth. So that's our response. And now we can start creating the custom request classes. So the first one I'm going to create, again, I'm creating a pair. So I'm going to call this get echo request. Okay. So this class is get echo request. And so what my goal is to make a custom request. Okay. And this is basically going to be, let's make a get request, add the parameters to the URL, and then we'll read the result using JSON. Rather than using like the org.json stuff, we want to read this as with the Json Parser, which we just added the dependency for. So first things first, in order to implement your own Volley requests, you do need this to extend the request class. Now, as you type in request, you may see that there's an awful lot of different request classes named requests that pop up. Is everybody seeing that?
Yeah.
It's important that you get the right one because these are not at all equivalent. So there are what, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's like 9 different classes called request. But which one am I looking for? Which one am I looking for?
Probably the Volley one.
Okay.
With the T.
Just noting, is that the one at the top of the list?
No.
It's not. So you do have to be careful about that, especially as you're bringing in things like this where there's multiple classes with the same name. Be very careful as you're typing, because otherwise you're going to accidentally import the wrong thing. Because if I were to just hit space here, more than likely it would immediately go to one of the other ones. But it looks like it didn't in this case, fortunately. So, by the way, you saw the one that's Volley is genericized, so I do have to specify what kind of thing does it return, right? So we're making a request. What is our result type? Well, a result type is that echo API response. Does that make sense? That's what we're getting back. So that's what I need to put in as the argument to the request class. So if you have, some other object, maybe a weather report, then that would be like the weather report that's coming back. If you have a user object that's coming back, will that be a user? So you have to kind of orient that to what you're expecting to return. All right, so we can kind of start building it out. One thing I know I'm going to need to be able to log some data for testing purposes. So I'm going to go ahead and add in that log tag is actually the first thing I'm going to do. Private static final log tag, and that is this class get echo request dot class .get simple name. So that's my tag I can use for logging. And then I can start building out the constructor. So in here, I'm going to say public, and we're going to say public get echo request. Right, so thinking about the parameters that I need, right? So what parameters do I need to receive to this constructor? Well, I want to send the message that the user typed in. I want to send that to the server. So that should be one of the things that I ask for. Does that make sense so far? But I also need to be able to give a response back. But remember, Volley works in an asynchronous way. I can't just say, I'm going to return it from a function. I can't do that in a synchronous sort of fashion. I can't say, well, let's just wait until this function returns. I have to provide a callback so that I can call back later and say, okay, I've got the response. Here it is. And actually, the way Volley operates, we need two callbacks. So the first one, I'm going to mark this as nullable because it's optional, and we want to treat it as such. Say, well, if you don't want to listen for the response, then fine. But typically you will, but we are going to allow that to be null. And so I'm going to say response.listener, and the listener then needs to be of the type of what we're returning. So for instance, we're returning effectively an echo API response. So that will be my listener. So any custom request that you provide, create, that always needs to include a listener and an error listener. So we're going to add that as well. And this is going to be response.error listener. And this is the error listener. Okay, so those are the arguments that I need to take to this constructor. So the message I want to send to the server, and what's going to hear about what comes back. Right? That's really all the arguments I want to provide in this case. Right? So the rest I'm going to figure out. The rest I know, basically. They're not variable. They don't need to be passed in. So here I want to make I do want to make a GET request. I know that. I do need to call the super constructor. Now, the super constructor needs a few things. And this is one thing to really pay attention to because it's maybe not intuitive. It's maybe not what you would expect. So the first thing that parent constructor needs is the method. So there we're just going to say method.get. So this request object is only for sending GET requests. Okay, that's fine. A lot of times you'll find this where your API, it's like, okay, it's this specific route for to do this task. So this is a GET request that we're going to be making. And then I also need to provide some sort of URL. That's the second argument. And the final argument is the error listener. Now it's worth noting, it's kind of interesting here. Notice that the request doesn't actually take the regular listener, the response listener. It just takes the error listener. That's because we have to save and call the listener ourselves. It will take care of calling the error listener if something goes wrong, but we have to deal with calling the response listener. Is everybody with me there?
Well, the URL is what you get if everything works right. Is that what you mean?
No. The URL is where am I getting the data from. The URL is not the data that comes back. Remember, the URL is what you type into the address bar. The response is what the data is that comes back. You with me, Paul?
Well, at a higher level.
It's a very important distinction. It's a very important distinction that to understand the URL is not the response. Okay? The URL and the response are not the same thing.
We're creating the request.
We're creating the request.
This is the outgoing thing. We're building it up. So we got our parameters there, the three that are up above, and I'm not really sure what we're doing here. I know you're explaining it, but I still don't track with the super thing and all that. All right. Go ahead. All right.
So the the super thing that we're doing here is that's the constructor in request. So if I were to go to the request class, control clicking on there, and actually I think if I just go directly here, control trick on super, you see the parent class, the request, it's got this constructor here that requires those three things. It requires a method, a URL, and an error listener. Anytime we're creating a subclass, we need to call that super constructor so that it can take care of initializing its fields. And in fact, it's important that that constructor actually has to run before we can run any code in our constructor. Is everybody with me there? Before you can write any code in your class, that parent constructor, that super constructor, has to run. That has to be the first thing that happens. Because otherwise you'd be accessing fields that are not initialized. Because you could be accessing fields and methods of the parent class, but they wouldn't be ready yet. So you got to make sure that you are actually required in Java to do this as the first thing. Okay. So what does that mean for the URL, right? How can I figure out what the URL is that I need to send?
If I remember from what I saw when you peeked over at the other side, it looked like it would be something like, oh, well, never mind. It's not defined there. I was going to say URL equals this URL, but I don't think that's right.
So notice I'm not passing in a URL to this code. And that's actually intentional, right? So because I want to keep the logic of how the request is implemented internal to this class. And actually the URL can oftentimes be one part of that. Sometimes it's okay to expose that as a constructor argument. More often than not, especially if we're going to take this approach, which I am here, that would be leaking an implementation detail out to the rest of the code that really shouldn't have access to it. So here, effectively, I need to build up the URL myself, right? And if we look at what I did yesterday, right, remember that we had this sequence of things that we did to build up the URL. We built up the URL, and then we provided it to this JSON object request. Does everybody see that? So if we look at that, right, okay, so I've got the message. Why couldn't I just take this code? Let's take this code that's building up that URL. Let's just drop it in here. So build up the URL, and then I'll call the super constructor with that. So everybody kind of follow what I'm doing? Everybody at the same place?
Yeah, I see.
So you should see on my screen that there's a bunch of stuff that's in red underline, and you should have the same thing on your screen. So looking at your screen, why is the constructor now, or why is the super in red underline? What is it telling you?
That it's supposed to be first.
Okay. What's supposed to be first?
It must be the first statement in the constructor body.
Right. So as I was kind of saying previously, your super constructor has to be called first. I can't put any code before that. That has to be the first thing that happens. And so this code cannot be before super. Okay. Well, now I've got a chicken and egg problem, right? So I can't run any code, but I can't run any code before the super constructor, but I also need to be able to run code to call the super constructor. Is everybody seeing the problem there? So I can't put this line of code before super, and I can't put it after, because neither one ends up working. I can't call the super again. Is everybody understanding the conundrum?
Yeah, it's
Okay.
we do. You have to define it outside of that then, right? You have to move the block from 20 up outside.
Nope,
Say line
can't
12.
do it. Can't do that either. Because if I take this up, if you're saying let's take this up and hoist it up to here, what's the problem now?
There's no way to get the message.
No way to get the message. In fact, I have the same problem. What's hidden in here, it's complaining about the message, but I actually have the same problem in that this line of code still runs after super. This line of code still runs after super. Nothing can run before super. Okay, so what are my options? Anybody give me an option? What could I do to make this work? There are at least two solutions here.
Well, can you just copy, you cut that, and then where it says URL, just put that whole thing inside super?
Yes, I could. That would work. That would be a very long line of code. Corey, were you trying to say something?
No, I was going to say the same thing.
Okay. So I could do that. In this case, is possible. Most of the times that's not an option. In this case, that does work, but it would be very messy. Another thing I could do is I could just say, well, let's give up on sending the message. What happens if I pass the URL in here? Well, I could do that, right? And that's one way to solve the problem. If I just say, hey, well, okay, maybe I can't do it here. I'll pass the URL in as a parameter. And that's actually where I find most students landing, is they just say, well, I can't do it, so I won't do it. Okay. But the reason I don't want to do this, right? Remember my whole goal of trying to find a way around this is to ensure that the encapsulation holds, that the details of how this request is done are still within the request object. That those details, those implementation details, are still hidden in here. Okay. So here's the kind of, we're gonna backtrack a little bit so I can, explain to you what the solution is here. So I'm gonna go back to this being a message. Okay. So a few things we know. Super has to be called first, right? And super needs to be called before you can access any methods, before you can write any code in here, and such. Well, why is that? That is there because otherwise, calling instance methods, accessing fields would be in an undefined state because they haven't been initialized, like the parent class has not been initialized. Does that make sense? So what we're trying to avoid is accessing instance fields and instance methods where things have not been initialized yet. Now, did you hear that word instance in there? That's what's important. Okay. So if it's not an instance field or not an instance method, the rules don't apply. So what I can do is I can write a static method, private static string. Okay, so this is a static method. Remember, static means that it doesn't need an instance to be executed, which means the parent class doesn't have to be instantiated yet. So I can build a method here. So I'm going to call it build URL. I'm going to take in whatever data I need. So in this case, I want the message. And then inside here, that will actually allow me to put that code. So I'm going to say, let's return, build out the URL. right? So I've got a private static method that does the code that I wanted to have. So everybody with me there? So this method I can take the message, it can spit out a URL, which is what I need. And because this is static methods actually can be called before the super constructor. So I can call build URL here before the static constructor gets run. Is everybody with me on that? So you can't call instance fields, and you can't write, basically normally can't write code there, but you can put things like expressions or static methods you can call earlier. Is everybody tracking?
Yeah, it's not something I would have come up with on my own. You know, I just kind of see it and accept it, and hopefully I'll understand it later.
Well, definitely understand it now. But this is why I wanted to go, one of the reasons to go through this example and to just demonstrate one of the tools in your bag, because this comes up. So this is kind of a common workaround that you need to do for constructors. Okay. So we've got that in there. And the next thing I want to do, I need to make sure that I save the values here as well. So I need some instance fields, and so we're going to save the values that we received into the constructor. So let's go ahead and save the message, and I'm going to save the listener, the response listener. But I actually, as it turns out, I don't need to save the error listener because the parent class already deals with that. So the only two I need to save are going to be the ones that are not saved, the things that are not saved by the parent class, which would be the message and the response listener itself. That'll change, quite a bit depending on what you're building out. But this is what it looks like in this case. Should look similar, but it's more than likely not going to be identical. Questions? Okay, so now that we've done that, we can get to actually implementing the main, overriding the main methods of the request that we actually have to implement. So you'll notice that this is still in red, and the reason that you still got a red underline up at the top is because we haven't overridden the pair of abstract methods that we need to override. And so one of those is parse network response. The other one is deliver response. I'm going to do these one at a time. So I'm going to start typing down here as parse network response. I'm going to go ahead and pull that out. Okay. So parse network response, what it receives is the data that we got back from the server. And so your goal is to take this, the goal of this method is to take the data that came from the server and turn it into, parse it, parse the JSON, parse the XML, whatever it may be, parse it and turn it into the format that you want it to be in. This method gets called on the background thread. So here we're still working on the background thread. The next method that we look at, which deliver, actually runs on the foreground thread. So that's part of why those two things are split up. One runs on the background and this one runs on the this one runs on the background, the other one runs on the foreground. Okay, so in the end, what we need this method to return is what's called a response, right? And so it's genericized with our type here. That came from being up here as request, so it's the same type that appears up here, same type that appears in our listener. It's what are we returning. Now, there's a few things I have to do. The first thing that I need to do, and this kind of breaks into 3 steps, so I need to parse the bytes, because we're going to be getting the data as bytes into a string. Okay. Step 2 is we're going to parse that string, which contains JSON formatted data, into an object. Namely, that's going to be into our API Echo API response. And finally, once we're done with all that, we're going to return the response. So that's kind of our 3-step process. Yep.
Is what's going on in line 37, is that also called serialization? I think we did that with Node a little bit, or is that something different?
It's the reverse. It's deserialization. So what we're doing in here in the parse network response here is we're deserializing. So serializing is the process of taking data or objects and turning them into an array of bytes. Deserializing is the reverse, where you take an array of bytes, binary data, and turn it back into objects. Does that make sense? So like if I'm sending data over the network, then I need to serialize it. If I'm receiving data, then I'm going to deserialize it. So in this case, we're receiving data. Okay. Now, in terms of parsing the string, one thing to know about the way HTTP works is you'll remember that there's headers that you can send along with the requests, and those headers provide a lot of metadata about how are you sending the request and what's in there. And one of those headers in particular tells you what character set the text was sent as. That's important, especially as you're dealing with different cultures, different countries, different languages, different servers and things. Your data may or may not come in the same character set. Okay, so we don't want to assume what that character set is. We want to accept it and read it from the headers, right? So if the headers tell us that this is UTF-16, then we're going to read it as UTF-16. If it tells us that it's UTF-32, we're going to read it as UTF-32. But the most common character set that's used for sending data on the web is UTF-8. So we're going to say, if you tell us what character set to use, we will use that character set. But otherwise, I'm going to just fall back to UTF-8. Is everybody with me there? So there's going to be a bit of boilerplate. This is basically a line of code that has to be in this method. You don't actually ever need to change it to anything different. But you do want to have a little bit of cursory understanding of how it works. So I'm going to create this variable called char set. So this is going to be the name of the character set. And to figure out what that character set is, I'm going to use one of the utility classes in Volley. So first thing I'm going to write here is going to be HTTP URL. HTTP header parser. So this is a utility class. And the method I want to call is Parse Character Set. Okay. Now, Parse Character Set takes 2 things. It takes the headers of the response as well as whatever your default character set is. So in here, I'm going to take that network response that we received, and I'm going to say response.headers. Right? So we got a network response in here. I'm going to say grab all the headers of that. And so it's going to go looking through there and seeing if there is if I remember right, it's the content type header, and try to parse the character set off there. If the content type header is missing, or it wasn't able to parse it for whatever reason, then we're going to fall back to UTF-8. So everybody with me there? So that's what that's saying, is use the character set in the header. Otherwise, if there isn't one, then just default to UTF-8. So typically your server, whether you're building it in Node or C# or if you're building or Python or whatever, when you send responses back, you need to include that character set. Oftentimes the server framework will just do that automatically for you. So it's usually pretty transparent. But when you're reading it here, you do have to pay attention to it. So the reason we need that character set is because it determines how we translate from numbers, which is what we're getting. We're just getting a long sequence of binary data, which is really just numbers. And I need to say, well, this number is an A, and this number is a B, and this number is a uppercase A or a lowercase b. And so my character set gives me that translation from numbers to characters. Is everybody with me there?
Yeah, it's 99% of the time it'll be UTF-8. We're just dealing with stuff here in the USA, right?
Right. Well, okay. And even just in the USA, it's not guaranteed to be UTF-8. It usually is, but there are enough servers in the US that may be giving you back, say, UTF-16, that you still need to worry about it. This becomes more of an issue, yes, as you go abroad, where UTF-8 may not be as, there may be other things that are a little bit more common, but large in part, pretty much everything in the US is going to be UTF-8 or UTF-16 or ASCII. One of those three are kind of the most common ones. So you don't want to just assume that it's UTF-8, right? So like if I had just written this line of code as character set equals UTF-8, right? I'm saying, well, let's just say it's UTF-8. Ignore what the headers say, right? And that would work as long as my assumption is right, right? That will work as long as the server is actually sending UTF-8. Is everybody with me there? But I don't want to make that assumption. I want to allow the server to change and evolve and tell me what character set it's actually using. Because otherwise I lock myself into the server only being able to send UTF-8, and a lot of times I don't actually have control over the character set that it's sending, because that may be somebody else's server, that may be somebody else's API. So I may not have any control over what that character set is. So avoid some issues before they happen. So once we've got the character set, I can actually parse the data. So now that I know what character set it's using, I can actually try to take the array of bytes that we've got and turn it into a string. So string has a constructor. We haven't really used the string constructor very often, but this is one of those cases where we do. So the string constructor that I'm going to use, and specifically, takes two things. It takes the byte array, which is the data. So this response.data is the array of bytes, all the binary data that came back. And the second argument I'm giving it is the character set. So the character set tells it how to read that binary data. Everybody with me? So basically I'm giving it sort of a lookup table. Okay. So that's how I'm going to get it into a string. Get it from an array of bytes to a string is first determine the character set and do the conversion. Now in here you'll notice that there's a red underline on that string constructor, and it's telling me that there's unhandled exception, unsupported encoding exception. Because what can happen, I'm just providing the encoding as a string. It doesn't know if that is a valid encoding. Or it may be that the server sent us an encoding. It says, here's the ISO 1234, but maybe our Android device doesn't support ISO 1234. So we could get an exception there if the server is sending an encoding that our device can't handle. Okay, so we have to catch that exception. So easiest way to do so, I'm going to actually just take the entire method, wrap it in a try-catch block. Because as it turns out, if anything goes wrong with this parsing process, we can basically give up. There's no way around it. If something fails, something goes wrong, we're done for. So I'm going to wrap a try-catch around all of that. And then at the end here, assuming we catch an exception, I do still need to return a response. Okay, I don't want to return null. It's very important that we don't return null here, because if we return null, we're telling the rest of the code that we actually got a response of null, which isn't correct. If we get to one of these exceptions, it says, yes, we got a response, but we failed to process it. We couldn't understand it. So what I want to do instead is return an error. And the way I do that is I'm going to say response.error, and I'm going to construct a new parse error. This is a volley class. So new parse error, and I pass in the exception to that constructor. So if anything goes wrong, we're going to be returning a parse error to say, hey, we failed to parse the response. Okay, so that means if, for instance, we don't understand this character set, then that's just going to go straight down here, and we're going to give up. It's like I don't know how to process that character set. Or if we determine that we default to UTF-8 and it turns out we can't process it as UTF-8, okay, again, we'll fall back down here. So if anything goes wrong, we just give up, because there's really not much more we can do. So once I've parsed it, once I've taken the bytes, turned them into a string, now I can actually try to parse it as JSON. So I'm going to say JSON, it's my JSON parser, is equal to a new JSON object. Okay, so I'm going to construct my parser, and then we're going to try and parse it. So what I want to get out of it is an echo API response. Okay, and that's going to be my object. And if that worked all good, if the way I'm going to parse that, so I'm going to use my parser, JSON, and I'm going to say dot from JSON. There's a few different variants of from JSON. You can give it a reader, you can give it a few other, you can give it a string here, which is what we have. So I'm going to give it that string, JSON, that we parsed up in line 42. And then the second argument to that constructor is what class do I want to process it as. So here it's going to be processed as echo API response dot class. So I'm going to take the string of JSON that we got and turn it into an echo API response. Okay, so that's all I need to do in terms of parsing it. If you look back at previous examples, it's the same thing we did last week, or I think the week before spring break. So we've got that. And then finally, I can start to return the result. Okay, now in terms of returning the result, I'm going to say return. Similar to what I have here, I need to say response dot success. Now notice success takes two arguments. So success takes the result that you've got out as well as a cache entry object. So if I provide here, I could say, well, let's return the object that we parsed, and maybe for the second I'll pass null. Okay, so the first argument is the data that we have successfully parsed, and the second argument is how do you want to cache that response. So remember that Volley has some caching disk-based caching built in. and provided for us, or it can do that. So that what it does is it's going to look at the, basically we're going to look at the headers of the response that we got back, see if we're allowed to cache it, and if we're allowed to cache it, then we'll save it so that we don't have to go ask for it again later. Now, if I pass null there, I'm saying don't cache this response. Every time you ask for it, every time I ask for to hit this request, hit this endpoint, we'll go get it again. No caching involved. Is everybody following with me there? But for GET requests, right, you usually do want those to be cached, right? So for GET requests, I generally don't want that to be null. I want to provide a cache entry that it can use to cache the object. This is another thing we literally just pull from the documentation, and from there, what we need is a cache.entry. I'm going to call this variable cache entry, and I'm going to use the same utility class that I had up here. So previously I used HTTP header parser to extract whatever the character set is from the headers. Here I'm going to use that HTTP parser to figure out should it be cached and how should it be cached. So I'm going to call parse cache headers, provide that the response as a whole. Okay, and so that's going to look through the headers on the response, determine if it can be cached, and if so, then we provide that down here. Any questions on this method, parse network response? The good news about this is most of this method doesn't change, right? So it's largely code that you can just say, okay, I can just copy and paste it. It's mostly just boilerplate. The only thing that's really going to change in here is this line 47, where we determine how we're going to, what class, what object are we going to parse it into. That's really the only thing that changes. Is everybody with me on that? The rest is pretty fixed. Okay. So we've written this method. This will deal with parsing the response. Again, this is happening on the background thread. And then finally, we return the result here. Now, this result doesn't actually get passed back directly. If I stop here, I won't be able to listen for the response. I won't be able to get this data. So in order to actually access that data, there's another method that you have to implement. And so under here, we're going to override the deliver response method. And so in there, if we do have a listener, the listener is not null. Don't want to get a null pointer exception because we didn't check. But if we did provide a listener, then we're going to call the onResponse method, providing our parsed response. So that's it. Again, the difference here is this one runs on the background thread, and this one runs on the main, the UI thread, which leads you to that transfer from the background to the foreground. So in this, in building this class, we've created our own custom request, and so we can do this anytime we need additional behavior, or we need to kind of bundle it together. So the main reason that we did this here is because I want to use JSON to parse my data. Is everybody with me? So the main reason I created this is so that we could parse it as JSON. Now, we've got this request type. We aren't actually using it in the application yet. So I do need to go back to main activity. And so back in main activity, remember we were in this onSend method. Happens when you click on the button. So what I'm actually going to do is I'm going to comment out all this code here. Right? We still need to get the message. We still need to create a request. Might as well comment that out too for now. So I still need to create a request. I still need to add it to the queue. But the rest of that logic is basically going to happen in our new class. So here I'm going to say request is equal to new get echo request. You remember we set that up so we need to provide a message first. So that's the message that the user typed in. Right, so we're passing some data that's going to be sent to the server. And then I need to provide listeners for the response, as well as listeners for the error. So when we get back the response, what data type is this going to be? What data type is the response listener going to receive?
Should be echo API response, yeah?
Correct, yeah. So it's going to get back an echo API response. I'm just going to call that variable response. So we want to do something in there if it's successful. And otherwise, it's going to fail. At which point I would want to say, well, let's do something about the error. Okay. So that's all I'll end up needing to do to create my request, because I've hidden a lot of the logic, right? I've implemented that into the request object itself. So I really just need to say, here's the data I want you to send, which is the message, and here's the code I want you to run when it completes, whether it completes successfully or whether it completes an error. Here's that code. So in the case that it fails, well, I want to log the error. That actually doesn't change. And I also want to show the error. I also want to show the error to the user by updating the text sheet. So those two things, what I do in the error case don't change. Now, what do I want to do in the case where it's we successfully received the response? Well, easy thing to do, probably just to go ahead and update the text that's shown. So I'm going to just say response text dot set text, and then let's just use string format to format that together so we can see a nice put together kind of the data that we receive. So I want the method space %s/n. I want to see the message that we got back /n, and I want to see I need some other %s there. So timestamp %s. And then we just peel those off the response. So response dot method response dot message and response dot timestamp. Okay. So we've written a fair amount of code, enough to be worried, enough to say, well, there's a lot of things that could go wrong because we wrote a lot of code without testing it. So let's make sure that we test it here now that we finally can. Now, I see one thing I forgot to do. I created the request. I forgot to add it to the queue. So request queue dot add request. Make sure I do that. Now what? Oh, it did finally go. It just took its time. Okay, so I sent the request there. Let's see if I change it. Test. Send. Okay, there it went through. Now you'll notice the method's coming back as null. Why is that? Well, because I forgot to send the method. So I need to go back into the request. And in here, when I was building up the URL, I added in the message as data we were going to send. I also wanted to add in another parameter which would say which method are we accessing. So append query parameter, say method, and here I'm going to say that the method is get. So I can add in additional things there, like, hey, I want some constant values in there. I want to add that in like this, rather than adding it into, say, the base URL here. Okay. Is everybody tracking on this kind of custom request idea?
Yeah, I don't know if it's just my emulator, but I think it crashed.
Okay.
It might be your emulator.
Might be your emulator. Definitely check Logcat to see if you can see why. And maybe it'll point you to the line of code in question. So that's one version of this that's building it up as a GET request, right? And so if I'm sending a GET request, right, it's normal. The normal way to pass data is through the URL, right? But if I'm going to pass data, if I'm going to say let's make a post request, you can still technically add it to the URL. That's still an option, but usually we pass it a different way, right? So if I'm going to make a post request, say from a web form, how do I usually post? How does that data usually get sent? How is a post request different from a GET request?
We're putting data out there if it's a post.
Okay. Not really true, because I could do the same thing and send data over the URL for a post request. So it's not just about the fact that you're sending data.
How is it different?
How is it different? So, Troy, you said we send it through an object we did with Node. What do you mean by that? And to be honest, we're not concerned about what the Node API was, because what we really care about is the underlying, what is the HTTP protocol, right? Because we're not obviously using Node here, but we're still using HTTP. Okay. Yes, it got serialized. Anybody else? How does that form data get sent?
Serialized.
Not what I'm looking for. So remember, every HTTP request or response, right, includes both headers and the body of the request. Okay, every request and response has headers and the body of the request or response. So, like if I'm getting data, if I'm making a request here, right? So I've got headers that I'm sending, and part of that is the URL. But when I receive the data back, you see we're kind of parsing headers. But the data, the actual JSON, is part of the body of the response. So if I'm going to send data, like with the post request, typically what we do is we send that data as what we call the body of the request. Okay, we send the data as the body of the request. That's the part you need to remember. Okay, so if I'm sending it through the body of the request, that means things like I can't just look necessarily at your traffic history and pick up your password, right? Because effectively you have to treat everything in the URL as public, because a lot of things along the way can see the URL. So we want to keep it in the post body. So if I want to implement a post request, I have to do something a little bit, I have to do a few things a little bit differently. So what I'm going to do is I'm going to duplicate this class, Control-C, Control-V, and I'm going to call this the post echo request. Okay, so we're going to start with basically the post and the echo. The post request and the echo and the get request, they're the same class, right? So we're going to just go through what are the differences, what are the things that you need to do differently. Okay, so first things, obviously, for post, I want to use the method post. Is everybody with me on that front? So I'm going to switch that to post as being the method. And then rather than putting all this data into the URL, I'm just going to directly pass the URL. And I could still use that method, right? I can hard code that here, right? That's one option. I could hard code that there. If I still needed to put some data in there, which happens sometimes, maybe I need to put some data in there. Maybe we keep it, and no, I'm just going to ditch it. I'm just going to ditch it. So rather than building a URL, I'm just going to say, hey, here we're going to go to API echo, and that's our URL. Okay, because we want to pass the data somewhere, some other way. Okay, so if I want to send basically form data, I want to emulate a form post. That conversion is actually pretty easy. Rather than creating this build URL method that we did earlier, what I need to do is override another method called get parameters. Okay, so I'm going to override the get parameters method instead. And so that's where we return whatever data that we want to pass as the basically as what were in the form fields. So this needs to return a map, and so maps in the interface, I can't directly create it, but I can create a hash map. And typically when I'm creating hash maps, I would prefer to use a linked hash map. Reason being is that the order of a linked hash map is guaranteed, whereas effectively the order of a hash map is random. So this will give us some predictability and make it easier to test things by using a linked hash map instead. So I'm going to construct that. So it's a linked hash map, key is a string, value is a string, because that's what I need to return from this method. Okay, so we kind of build that out, create my parameters, and I can add things to it, and finally when I'm done, I'll return it. So in here we need to say, well, what are the things, what are the pieces of data that I want to provide? Well, I want to provide the method. I want to provide the message. So in here, I'm going to say params dot put, and so we're going to put the method into there. Put method, and this is post. Really, this is, I mean, what I'm doing here with the method and the message is really not all that important. Just to remind you, this is just test data that I'm sending back and forth just to demonstrate that it works. So the actual data that you're putting in here is going to be and should be different. So these 2 lines of code are not things that I would expect to see in your application. Okay. So if we've got that, right, so now we're saying we want to add these parameters. I actually don't need to mark this. This doesn't need to be marked as nullable because it will always return an object. It won't return null, and it's not going to throw an auth exception, so we don't need that either. Okay, so I've implemented this params method, which builds up that hash map, and that's really the big change to make, is to pass things as post parameters. You just implement get params. And in here, back in main activity, to make sure that I'm calling this one, I'm just going to switch that over to post echo response. And so when I run this, we should see, okay, switched over, making a post request, and you see that the data is being passed. So we're sending the post, we're sending the method and the message, and we're getting those back from the server. So the big thing you have to know, if you want to send a post request, is you need to implement this get params method. Another thing worth noting, and you don't have to do this, if we're making a post request, we know we're making a post request, then we also know that we don't need to cache the data. If you provide the cache entry, it will still work. So it's perfectly fine to leave this in here. But we know in terms of this, if it's a post request, we shouldn't be caching the response. So we can just go ahead and set the cache entry to null with no side effects in the case that we are a post request.
Okay. I was busy coding and making sure that it worked. So what is this doing exactly? Because we're getting information, right, from an API.
Mm-hmm. So we're sending information to an API and we're getting information back.
Yeah, forgive me. What are we sending exactly?
So what are we sending? What does it show here is what we're sending.
Okay, so it doesn't really have utility. We would get a response in any case. It's just to do it.
This is just a demonstration.
It just ignores it.
Huh?
The server will just ignore it.
Just ignore what?
Well, you're sending data, right?
Okay.
It doesn't matter if you send data or not. It'll give you the same response whether you send it or not, right?
No, it's sending back the data. So, for instance, if I say test here, you see how test comes back. So, like whatever message I type into this field, I'm sending it to the server and getting that same thing back. It's just echoing whatever.
Oh, okay.
That's where the name echo comes from. It's just echoing whatever we sent to it, and that's just an easy thing to test, right? It's an easy thing to say, okay, I can send some data, send it back. If it's just like return whatever data I send to you. Does that make sense?
Yeah, I understand now.
Like this is like echoing data back is not a real world useful thing. But it's good for demonstrating how this works. It's good for demonstrating that we can send data and that we can receive data. Cool?
Yeah, I get it now. Thank you.
Yeah. So that way we know things are functioning and we can extend from there. So that's good. So we've got we can make get requests, we can make post requests. and we can build our own responses, build our own requests using this, build our own custom request objects. Okay. So before we do the next thing, are there any more questions about creating custom requests?
Line 46, 47, and 48.
Uh-huh.
How does it know which one to put which? I know they're both strings, but that's if it was say like an int or something like that instead, would it just automatically go to the right spot? Or
so in this context, these both have to be strings. In this context, they have to be strings.
Always a string.
Yeah, because remember HTTP is basically a text-based protocol. So if I'm passing things back and forth in terms of like posting data, anytime you actually do a form submission on any website, that data has to be turned into text and sent to the server. You can't send it as a number. Like I can't send the number 5, but I can send the string 5, but I can't send the number 5.
Okay, it's always string.
Always string. Yeah, it's always string. So the first one's the key, the second one's the value, but for this purpose here, it's always string. It can't be anything else. Okay, so last topic to discuss is how do we get this to work? How do we get Volley to work with the work manager? So I want to go over that. I do think we need a quick break, quick intermission before we get on to that. So why don't we take a 20-minute break here, and let's come back at, what would that be? 2:15? Okay. So let's finish this off. So we're going to talk about how do you get the work manager to work with this. So we've looked at creating our own custom requests, which is definitely something you're going to need to do with Volley. But also we want to look at, hey, I want to be able to run these requests still if their app's not running, especially for like notification purposes. I need to be able to run it on a periodic basis and such. So I need to get the work manager to interact and to be integrated with this. So first thing I want to do is kind of like where we start with a lot of these other projects is I need to create an application because I want to make sure that this request queue is shared and used both by the activities as well as the workers. So I'm not trying to do a whole bunch of requests at the same time. Okay, that'll help get them batched up. So I'm going to create a class called myApp. This is going to extend the application class. I need to have a log tag here, private static final, because I will want to do some logging. Private static final log tag is equal to myApp dot class dot get simple name. I also want to override on create, and I need to have a place to store the request queue. So private request queue, and in here I'm going to create that request queue. So this is going to be volley dot new request queue, and this requires a context. Normally when we create a request queue, we want to make sure that we call get application context to ensure that we're getting an application context instead of an activity context. As it turns out, because we're already in the application class, this is unnecessary because it would return the same thing. So if you're writing it into the application class, you can just go with this. Otherwise, anywhere else, you want to make sure you're getting the application context, not an activity context or such. Okay, so that's important there. And last but not least, I want to provide a getter, right? So now anywhere in the code, I can grab this request queue and use it. Okay, just a reminder, anytime we create these applications, we do need to link it up in the manifest. So I'll do that real quick. Android name is .myapp. So I need to just remember to put that one line in there. So is everybody tracking here with what I'm doing to set up the application? Everybody caught up?
I got a red error on on create, and it says cannot resolve symbol. I have auto import, and I got volley in there.
Can't resolve what symbol?
Let me take a closer look.
You might need to check that it extends application.
I think I found my error. Okay. I didn't instantiate it.
Okay. All right. So that's it. So we've set up our application class. That's really all we need here. One quick thing I might want to do now that I've got a central place for that, for creating the request queue, I actually do want to go back to the main activity and grab it from there instead of creating a new request queue every time. So, which is what I was currently doing. So I'm going to grab the application, variable to save it in, so app equals my app, and get application. And so rather than saying new request queue here, which would create a new request queue every time, I'm just going to say app.getRequestQueue. So similar how we set up the data sources and we say we don't want to create the data source every time. I don't want to create a request queue every time. So I'm going to be using the one with the application created. Okay. Back to the world of figuring out how to build this worker. So I'm going to add a class in here, new Java class. We're going to call this my worker. Okay, so it's going to be my worker class, and basically all I'm going to do is I'm just using this not to show notifications or anything like that. I'm just going to say let's run a worker and show you what would be necessarily to get it running in the first place, and you can kind of build on from there and make it do things yourself. So here, you remember normally when I create a worker, I'm going to say extends worker, right? This is what we've done before, right? So we said it extends the worker class, right? The catch is this worker class actually assumes that whatever I put into do work is synchronous work. Is everybody with me there? So this worker base class doesn't work, no pun intended, if you've got an asynchronous thing you need to do. Okay, which Volley is asynchronous because it's already doing this on another background thread. Okay, so everybody kind of following with me? So like when I have do work, at the end of do work, I need to return the result. But I can't do that because there's no like sequence from top to bottom that I can set Volley up in where I would sensibly be able to return the result from do work. Okay? So worker doesn't work here. What we need to use instead is a different base class. And so, in fact, if I look at the worker class itself, you'll see that worker actually extends another class. So everybody see that? So I went control, click, and go to the worker class. So the worker class is an abstract class which extends listenable worker. So listenable worker is actually our base class here. Well, as it turns out, listenable worker does support asynchronous work, and that's what it's actually designed for. So worker is only for synchronous work, but listenable worker allows us to do things, offload things onto another thread. So we're going to use listenable worker here instead of worker. So everybody got that? Converted over to listenable worker here.
Yeah, I got that. In the application, did you copy and paste a bunch of stuff all at once?
Not per se.
I must have been looking at something else.
Okay.
Yeah. Okay. All right. Never mind. Let me. Okay. I'll copy it later.
So in terms of the worker, that's the big difference, is that you need to implement listenable worker instead of worker. And when we implement the listenable worker method, worker class, instead of implementing do work, we're going to implement start work. And start work has a little bit of a different signature, which leads to some things that we have to do. So before I get going too far, let's go ahead and add another log tag in here. Private static final string log tag is equal to my worker dot class dot get simple name, because I want to be able to log some information to be able to see that this is actually working. I need a reference to both the application and the request queue, so I can queue that up and share that same request queue with the activity should it be running. And so application, request queue. Okay, so those are my fields. We now need to add a constructor. So public, actually I'm just going to start by typing my worker. Maybe I do need to do it that way. Okay, so public, my worker, and so we want to create a constructor here. Now, just like the constructor to the worker class, this takes both a context and a worker parameters object, neither of which can be null, so we're going to annotate them with the non-null annotation. Non-null, context, and here I'm going to do non-null worker parameters, params. Okay, so we're going to take those two things in and call the superconstructor. So the superconstructor just needs those two things directly passed to it, the context and the params. Okay. I need to initialize these two instance fields that I've got here. So for instance, app is going to be just take the context and cast it to my app. And the request queue, just like we saw in the main activity, is going to be app.getRequestQueue. So cool. Now, you'll still see stuff is in red, right? So stuff is still in red because we need to actually implement the key method of the listable worker worker class. So I'm going to say implement methods. and so it's going to give me this option. I want to create the start work method. Okay, so it's called start work. It returns something interesting. It returns a listenable future that is a result. You remember that do work, previously when we were working with workers, do work simply returned a result, right? The result is what we want out of this. But we were able to return a result because we could immediately get it. When the function was, when the do work method was done, then we were done with our work. But this method just starts the work. It doesn't do the work. It starts the work. Does everybody follow with the differences there? So I'm starting the work, not doing the work. Okay. So remember, if I create a request and add it to the queue, right, the request doesn't get filled or run automatically. It doesn't get run on the same request that adds it to the queue. It gets run at a later time or asynchronously. Okay. So I need a way to kind of bridge those worlds and provide the result when it's ready. And that's where the listenable future comes in. Is it allows me to provide that when it's ready. Now, the listenable future interface is actually rather hard to implement. So we don't want to do that ourselves. We want to use one of the implementations of listenable future that Google has provided. And so we're going to be using a class that kind of does this conversion between our volley callbacks, the response callback, and the error listener, the response listener, error listener, and turn those into, basically these futures. Now, the place that we're getting that class, and this is a thing to point out, we've already added the dependency for it, but you do need to remember where it is. So the thing that we're needing here is this androidx.concurrent. That's where this comes from. Okay, so if you don't have this dependency, you'll be able to create a listenable worker, but you won't have this interop class. You won't actually be able to have this particular class that we need. So what we're going to write into here is I'm going to say return, not return null. I'm going to say return callback to future adapter. Callback to future adapter dot get future. So what this method is, it returns the thing that we need, but we have to provide it a method of our own. So it takes a method, takes a callback that goes from what would they call a resolver to our code, right? So here's where we're actually going to put the interesting bits of what we're doing, is inside of this lambda method. Okay. So I want to create a request. Remember, if I want to initiate a request, I need to do two things. Create a request and add it to the queue. So I'm going to do that here inside of this callback method here. So request is equal to new post echo request. Okay, and so let's just say we need to provide a message. So I'm just going to say my worker is the message. I also need to provide, remember, two callbacks to this. What do I want it to do if it's successful, and what I want it to do if it fails. So this first one would be an echo API response. And the other callback is a volley error. And I am missing a comma up here. There we go. Okay, so if things go good, we're going to do something. If things go bad, we're going to do another thing. Now you'll notice we're getting this resolver thing here. we haven't touched that yet. We're going to use it here in a minute. And basically what I need to do is if it succeeds or fails, those callbacks are where I'm going to tell the resolver that we're done. So in here, let's say it's successful. Well, then I can say resolver dot set, and we're going to set the result to success. So we're good. But if something doesn't go right, so we get a volley error, I'm going to say resolver dot set. Now I could set this to a few things, right? So I could set it to failure. So if I set it to failure, say, well, it failed, give up on it. And so this worker would not get rerun. But I probably want this to retry at some later time because it's probably going to be a network related thing. So I'm going to say, well, let's return retry. So in this callback, we're saying set it to success. Here we're setting it to retry. By the way, I need to make sure that I add this to the queue. So request queue dot add request. So what will happen is we're going to start the request, and then at a later point it'll finish. At that point, we're saying, okay, now provide that back to whatever's waiting for the worker to finish as the result of the worker running. So there's just kind of a few layers of abstraction that you have to have there in order to use Volley with your workers. That's kind of how you got to set that up. Now, I probably want to do something, in those cases, at least so I can see what's going on. So an easy thing to do right now would be to just log either the error or the success to see if this worked. So log tag, and here I would say, well, we've got an error. Let me write out the message. Error dot get message error, and if it's successful, log dot I and log tag. And so here I would say maybe we just say success. And so when I run I forgot I still need to actually enqueue the worker, right? So the idea is we're going to log success or we're going to log error, and so we can see if it succeeded or failed. Got an extra S. Okay, so we need to go back to the application class because I still need to enqueue this worker. Now it looks like, oh, right. I still got a red underline here because I'm not returning anything. So what I want to return is the request. Return request. So I'm going to return the request from there. And you go back to the app, and we need to actually schedule that worker to run. So let's make a method. We'll call it schedule workers, and we'll call that from onCreate. So schedule workers. And this will be private void schedule workers. And so I want to say, let's build up a worker. And so I'm going to copy and paste some code over from my other screen to make this easy. So when we schedule a worker, we're going to say, okay, let's create get the work manager. We need to set the constraints. So this is only going to run if we're connected to the internet. And then I'm just going to do a simple one-time work request. It's going to have that constraint that it has to be connected to the network, and it's going to run at least 1 second later. So that should have it happen almost immediately when the application starts. And then finally enqueue that. So if all things go correctly, I should see the word success. I should see that message appear in the logs as soon as I start the application.
How did you get that so fast, schedule workers?
I had this on another, I copied it from my other screen.
Oh, okay. Can you dump that in the chat?
Yeah, I can. Long story short, I did this already earlier this morning to make sure I had all the code straight.
Okay, thank you.
And so it looks like at least at first run, this came out with a timeout error. Let's try it one more time. I feel like this happened the other time I tried to do it. Yeah. So the first time, for whatever reason, it timed out. I'm not sure why. The second time I ran it, I got success. Right. And so that's kind of my setup there. I probably want, if you wanted to look at the actual data here, I could add a little bit of code to spit out the data that's inside of the response. So rather than just logging success, I might say, well, let's log the method and the message and the timestamp that came back, and we'll just use string format for that. So that would give me here, right? So we can see method, my worker, timestamp, awesome. So it's working, right? And so obviously, in your exam, in what you do for your labs, what you do for your final, you don't need to. You don't need a log necessarily the same way I'm logging here. That's just a way to say, hey, here's what's happening. We make sure that we made sure that we got the data and that it's working its way through. All right. Any questions?
Nope.
And this whole code example will be up there on GitHub. You can pull it down and kind of play around with it. But this is how you do, that covers two things: how we make our own custom requests, as well as how we get things working with workers. So for notifications and such like that. So if you looked at taken a chance to go look at the lab for Volley lab assignment?
No, I didn't see it. It's probably been updated. Yeah.
I think I haven't changed it. It's the same thing. It should be the same thing that was up there. So what I've asked you to do, pull it up here so everybody can see it. Yeah, let me just zoom in. There we go. So for the lab for this, I want you to take your project that you started for lesson 7 and 8. So you should have started you have an app that connects to a REST API. What I want you to do is refactor it, copy it over to your new Unit 4 repository, and refactor it to use Volley instead of HTTP URL connection. And I want you to refactor it to still parse it as, it's still going to parse it as JSON, which means you're probably going to need a custom request, which means, well, you'll definitely need a custom request. And use the kind of what we showed here. You can look at 17 and 18 for an example, as well of the reading, as well as what we did today for how to create that custom JSON request sort of thing. And then we just covered out how to use the work manager and Volley together. Cool.
Okay, so we just use the rest of the time today to work on it, and you can ask if you get questions.
Yep.
Or anything.
I will be here for questions, but basically that's what I'm asking you to do: is take a lab, take the project that you did previously, and convert it over to Volley. So you can kind of see, what does it look like before and after, and how is that different. Yeah, and tomorrow is a lab day as well. Reminder, yes, I will be out, so Mr. G will be here covering for me. And obviously taking attendance. What's up?
Oh, nothing. No,
Okay.
it's just all right.
So that's it. So get to work on it. You want to finish these up by the end of tomorrow. Given that you should already have a working project, it shouldn't take too much to convert it. I mean, basically, as you've seen, that it's for the most part simpler using Volley than using the code that you've already written. So it should lead to a simpler program than what you've already done. So that's it. And then next week we'll talk about retrofit, which is the next part of that lab worksheet.